Okay guys, today we're looking at how we use the linear relationships. Now what I first of all want to explain to you is the word variable. Variable is something that's in a mathematical problem that can change, okay, because it can vary. And we use a letter, usually with what it starts with, to represent it. So what I want you to look at over here is, says for each statement, let me get my pointy thing, for each statement define each of the two variables involved. So we've got the volume of water in a water tank increases during a day of heavy rain. So what do you think we're looking at there? Well, first of all, we're going to be looking at the volume, and then we're going to be looking at the time, because we want to know how long it takes for it to increase. Okay, and you could call that V and T. Another one is the distance. It says the average speed of a car as it travels over the distance. What are we looking at? We're looking at a distance, and we're looking at the speed of the car. So we could say S and we could say D. All right, so that's important for you to understand. Okay, let's move this up. Define all the variables that you are using in the following situation, and then write a linear equation to represent the total cost. Okay, so we're going to start off, let me get a color here. We're going to start off, it says the cost of a building project at school. So I would first of all put C for cost. Okay, consists of $1,000 fixed cost to cover the material. So I would put an F for my fixed cost. Okay, and a variable cost of labor, which is calculated at a fixed rate of $30 per hour. So labor, put an L, and that was labor. Okay, so we've got our C, our F, and our L. But now we have to work out what they're really wanting us to do. Okay, so they're saying they want to know what the cost is. So we're going to go start with that, C equals, okay, of a building which consists of $1,000 fixed cost. So we know that it is $1,000. And to cover the materials used, and that's going to stay. So we don't need to have that because it's not a variable. Okay, so we know it's going to be $1,000. No matter what happens, it's a fixed cost, it's $1,000 to cover the materials, and a variable, that's our second variable, cost of the labor, which is by a fixed rate of $30 per hour. So we added on plus, we said we're going to do L, but L has to be times by 30. So we go 30L, because every hour we're going to add on another 30 and another 30. So the cost is equal to 1,000 plus 30 times L, but we put 30 right in front of L. Okay, let's look at the next thing. All right, now this is something that you need to work out. What they're going to say to you is they're going to give you this. They're going to say a tap is left dripping at a constant rate. The number of liters of water wasted is shown in the table below. So you've got the number of hours the tap is left dripping, 0, 2, 6, 11. The number of liters in the water wasted, 0, 10, 30, 55. First thing that's very important, you need to work out what do you do to this number to get this number. So have a look. What do I do to 2 to get 10? What do I do to 6 to get 30? What do I do to 11 to get 55? Have a little think about it. It's definitely timesing or dividing. It's not adding. Yes. Okay, let's hopefully you got it. You have to multiply that number by 5. By 5, by 5. Do you see that? Okay. Then it says A. Plot the points shown in the table and join them to form a graph of this relationship. Label tells you what to label the axes with. Number of hours left, tap left dripping. On the x-axis, a number of liters wasted, W, on the x. So you know that you've got to go x-axis goes across. You're going to do your number of hours. So your number of hours goes 0, 2, 6, 1. I would maybe make them go to 15, and I would make them go to 1. So 1, 2, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. And then it said that your numbers of litres wasted, this one, you need to do it on the y-axis. So you need to do it here. I think I would go in fives all the way up, 5, 10, 15, 20. Remember to label it. Once you've labeled it, remember you've got to plot where they all, so 0 and 0, 2 and 10, 6 and 30, 11 and 55. And once you've done that, you answer the question, is the relationship linear? Because then you need to join your line. If it's linear, it means it's in a straight line. And then you need to tell them, well, if you've got 3 hours, so if you changed one of these numbers to a 3, what would the water be wasted? And remember what we said we did. We multiplied it by 5. So you should be able to answer that. All right, I want you to go and give this a go.